Hello, dear students. We are discussing the ACES Final Examination 2024 question paper. That is the previous year chemistry question paper. In the previous video, we have discussed up to question number 15. Now, I am going to discuss in this video from question number 16. In question number 16, it is asked, what is lanthanide contraction? What are the consequences of lanthanide contraction? This is the answer. The gradual decrease in the atomic and ionic radii of lanthanide elements is known as lanthanide contraction. This is due to poor shielding of 4f electrons. Consequences of lanthanide contraction: small change in the atomic radii because of lanthanide contraction leads to difficulty in the separation of lanthanides. B. Due to lanthanide contraction, these elements occurs together in natural minerals and are difficult to separate. C. Due to smaller size but higher nuclear charge, the tendency to form a coordination compound. Next, come into the question number 17. Explain why TiH2O whole 6 positive is violet in color. Hexaaqua titanium 3 ion is violet in color. Why? Answer is given. TiH2 whole 6 positive is an octahedral complex. There are 6 ligands in this compound. The ligand present in this compound is H2O. There are 6 H2O ligands connected with titanium. In the complex hexaaqua titanium 3 ion, the titanium atom has oxidation state of +3. Its outer electronic configuration is 3d1. It has one unpaired electron. This unpaired electron is excited from T2Z level to EZ level by absorbing yellow light and hence appears violet color. This is the diagram. Transition of an electron in TiH2 whole 6 positive, and this which is also called as DD transition. And the colors are shown by the coordination compounds due to the DD transition. Question number 17, another question is given, which is NiCl4 2 negative is paramagnetic while NiCO whole 4 is diamagnetic, though both are tetrahedral. Explain why. This is the answer. In NiCl4 2 negative, Ni is in +2 oxidation step with the configuration 3d8. Also, Cl negative ion being weak ligand, it cannot pair up the electrons in 3d orbitals, hence it is paramagnetic. In NiCO whole 4, Ni is in 0 oxidation state with the configuration 3d8-4s2. In the presence of O ligand, the 4s electrons shift to 3d to pair up 3d electrons. Since it has no unpaired electron, hence NiCO whole 4 is diamagnetic. This is the answer. Next, come into the question number 18. Draw the structures of geometrical isomers of FeNH2 whole 2 CN whole 4. As we know, geometrical isomers are of two types. One is called cis, another one is called trans. This is the answer. Number 18. Out of the following two coordination entities, which is chiral optically active? Explain. Answer is given here. The coordination for an object to be chiral is that it cannot be superimposed on its mirror image. The two entities are represented as like this: cis isomer, trans isomer. Out of the two, cis is chiral, that is optically active. Next, coming to the question number 19. Describe a method for the identification of primary, secondary, and tertiary amines. Also write chemical equations of the reactions involved. Answer is Hinsberg test is used for the identification of primary, secondary, and tertiary amines. Benzene sulfonyl chloride, formula is C6H5SO2Cl, is known as Hinsberg reagent. It reacts with 1 degree and 2 degree amines to form sulfonamides. The reaction of benzene sulfonyl chloride with primary amine yields N-ethyl benzene sulfonylamide. This is the reaction. The hydrogen attached to nitrogen in sulfonamide is strongly acidic due to the presence of strong electron-withdrawing sulfonyl group. Hence, it is soluble in alkali. In the reaction with secondary amine, NN-diethyl benzene sulfonamide is formed. This is the reaction. Since NN-diethyl benzene sulfonamide does not contain any hydrogen atom attached to nitrogen atom, it is not acidic and hence insoluble in alkali. Tertiary amines do not react with benzene sulfonyl chloride. This is a method for the identification of primary, secondary, and tertiary amines. Next, coming to the question number 20. The time required for 10% completion of a first order reaction at 298 Kelvin is equal to that required for 25% completion at 308 Kelvin. Calculate energy of activation EA. Solution is given here. Dear students, please write down the time required for 10% completion of a first order reaction at 298 Kelvin is T1 is equal to 2.303 by K1 log 100 by 90 R naught by R. Initial concentration, suppose initial concentration is 100. So after 10% completion, at time T1 becomes 100 minus 10, 90. The time required for the 25% completion of a first order reaction at 308 K is T2 is equal to 2.303 by K2 log 100 by 100 minus 25, that is 75. Since it is given T1 is equal to T2, so put the value of T1 and T2, you will get K2 by K1 is equal to log 4 by 3 divided by log 10 by 9 after calculation. If you do the final calculation, you will get it K2 by K1 is equal to 2.73. From Arrhenius equation, we have log K2 by K1 is equal to EA by 2.303R T2 minus T1 by T1 T2. Put the values, log K2 by K1, which is of 2.73 is equal to EA by 2.303 R. T2 is given 308, T1 is 298. You put these values, do calculation, you will get 0.436, which is the value of log 2.73 is equal to EA by 2.303 into 8.314 into 10 by 91784 implies EA is equal to this, and after final calculation you will get the value EA is equal to 76.623 kilojoule per mole. Next, coming to the question number 21. Write the products of the following reactions. Answers are given here. In this reaction, use Markovnikov's rule. When HBr reacts with a double bond, then this product will form. Hydrogen will attach with that carbon in which more number of hydrogens are present. So hydrogen will attach here and negative part will attach here. Similarly, in this case also, use Markovnikov's rule here also. This is the peroxide effect or anti-Markovnikov rule. Hydrogen will attach with that carbon in which less number of hydrogen is present. So hydrogen will attach here and negative part will attach here in this reaction. Here also use Markovnikov rule. Next, come into the question number 22. How will you bring about the following conversions? Ethane to bromoethene. So this is the ethane, CH3. React ethane with bromine water in presence in UV light and heat. The product will form this bromoethane will form along with HBr. Then react it with alcoholic potassium hydroxide. Ethene will form CH2 double bond CH2. In ethene, use these two reagents, bromine and CCl for carbon tetrachloride. You will get weak dibromide. In weak dibromide, use this reagent, alcoholic potassium hydroxide, then bromoethane will form. Next, bromomethane to propanone. This is bromomethane. When bromomethane reacts with magnesium metal in presence of dry ether, then Grignard reagent will form C3MgBr, methyl magnesium bromide. React with ethanol, then propan 2-ol will form. React this alcohol with PCC, pyridinium chlorochromate, in presence of copper at 250 degrees Celsius, propanone will form. This is the final product. Next, benzene to biphenyl. This is benzene. React it with chlorine gas in presence of aluminum chloride. It will form chlorobenzene. React chlorobenzene with sodium metal in presence of dry ether, biphenyl will form. This is the final product. Next, 22D, ethyl magnesium chloride to propan 1-ol. This one is ethyl magnesium chloride. React it with methanol aldehyde. Then this product will form. Add water. Then propan 1-ol will form along with MgOHCl. Question number 23. Draw the structures of all the isomeric alcohols of molecular formula C5H12O and give their IUPAC names. These are the isomeric alcohols. This is pentane 1-ol, 2-methyl-butane 1-ol. What are isomers? Do you know what are isomers? The molecular formula is same, but their structures are different. Those are called isomers. All isomers are shown here. Final one is this one, 2-methyl-butane 2-ol. Next, question number 23, or give the structures and IUPAC names of the products expected from the following reactions. Catalytic reduction of butanol. When butanol is reduced in presence of nickel or platinum or PD, palladium, then butane 1-ol will form. Next, dehydration of propene in presence of dilute sulfuric acid. Propene, add water, in presence of dilute sulfuric acid, what will form? Propan 2-ol will form. Reaction of propanone with methyl magnesium bromide followed by hydrolysis. Propanone with methyl magnesium bromide, and this product will form at first. Then add water in it. The final product will be 2-methyl propan 2-ol.